Hey everyone. So we usually think of computers as these perfect, flawless calculating machines, right? Well, what if I told you that underneath the incredibly advanced AI we rely on today, there's actually a physical engine that's basically just guessing, operating on assumptions, approximations, and even secret proprietary tables. Today, we're diving into this explainer to expose a massive hidden hardware flaw, and we're going to see why fixing it is literally the only way forward if we want trustworthy, accountable AI.
Okay, here's our roadmap for today. We're going to cover the hidden AI hardware flaw, compare the gambler versus surveyor, look into non-determinism and identity loss, explore the precise surveyor solution, and wrap up with forensic accountability in AI. Let's get right into it.
Section 1. The hidden AI hardware flaw.
So let's kick things off with a huge, high-stakes question that totally challenges our basic assumptions. If you ask a computer, hey, what's 1 plus 1? You fully expect an absolute, undeniable 2, right? But what happens when you ask it to calculate the square root of 2, or process, billions of parameters in a massive neural network? The truth is, at the physical hardware level, it isn't actually giving us an exact answer. It's giving us a highly educated guess. Crazy, right?
Just look at this staggering number on the screen, 80 to 90%. That is the percentage of AI compute cycles that are actually just tensor operations relying on approximations, not exact math. So when large language models or agent networks are doing their heavy lifting, they're mostly using hardware that fundamentally just guesses the nearest mathematical truth rather than calculating an absolute ground truth reality. And listen, this isn't just some software bug that we can easily patch. This is a hardwired, physical reality of how our modern AI server farms operate today.
Moving on to Section 2, the gambler versus the surveyor.
To really wrap our heads around this flaw, we have to look at two very different parts of a computer's brain. First, we have the floating point unit, or the FPU. Think of this as the gambler. When it hits complex math, like heavy matrix operations for AI, it basically throws darts at a dartboard to approximate the answer. Now, it's incredibly fast, but at its core, it's just an estimation system. On the flip side, we have the arithmetic logic unit, the ALU. This is the surveyor. The surveyor deals strictly in exact, deterministic truths. 1 plus 1 is 2, every single time. The problem we're facing, current AI relies almost entirely on the gambler, and that is a massive issue when we desperately need undeniable accuracy.
Which brings us to Section 3, non-determinism and identity loss.
Okay, let's talk about non-determinism. Because the FPU is approximating answers, chip manufacturers, companies like Intel or ARM, actually burn their own proprietary, completely secret seed tables directly into the silicon to help the gambler guess. What does that mean for us? Well, it means your computer's approximation of the square root of 2 might actually be slightly different, down in the decimals, than my computer's. It completely lacks hardware-level consistency. The underlying physical math is literally a trade secret. And because of that, getting exact mathematical reproducibility across different machines, it's physically impossible.
You can think of what happens inside an AI model as a sort of wood chipper effect. Step 1, the AI ingests source data. Maybe that's a copyrighted book, financial records, or open source code. Step 2, the FPU hardware approximates the math of that data using those secret proprietary chip tables we just talked about. And finally, Step 3, because that math was just a guess and not a precise trackable calculation, the original data's exact path is lost forever. The FPU basically acts like a giant blender. You know exactly what went into the blender, sure, but you absolutely cannot reverse engineer that smoothie back into the exact fruits it came from.
And the legal and financial fallout from this wood chipper effect is it's staggering. When the gambler approximates data, it completely wipes out the identity of the original contributors. As the source material calls it, this leads to the liquidation of contributors. Think about it. Without an exact deterministic mathematical path, you can't establish a chain of title. You can't prove provenance. This creates a really massive, basically unmanageable liability for intellectual property and copyright in our digital age.
So how do we fix this? Let's look at Section 4, the precise surveyor solution. If the FPU gambler is destroying our ability to trace information, the fix is actually pretty clear. We have to shift our AI operations away from the gambler and hand them over to the exact ALU surveyor. Let's break down this trade-off. Yes, sure, the gambler is extremely fast right out of the gate, but its proprietary seed tables make it completely unauditable. The surveyor, however, operates on universal exact hardware. Now, it might be slightly slower on that very first initial calculation, but, and here's the kicker, because the result is mathematically absolute, it's forensically accountable. You can store that exact result on a universal ledger and share it across millions of machines instantly. without anyone ever having to guess again.
By taking the time to rewrite our core math functions to rely solely on the exact ALU, using languages like C and WebAssembly, we literally change the game. This restores Noether's theorem, which is a principle in physics that basically gives us symmetry and reversibility. We can actually work backwards. It also helps us avoid what researchers call the 50% critical line, which is this point where FPU approximation errors compound so much over repeated tasks that the data just becomes statistically useless. By using the surveyor, we create a system that doesn't guess but surveys reality perfectly, giving us absolute hardware-level determinism.
And that leads us to our final section, Section 5, Forensic Accountability in AI.
Okay, the real-world stakes here are incredibly massive. We are hurtling toward a future where AI is going to be tasked with high-liability fiduciary duties. We're talking about AI managing enterprise finances, negotiating complex legal contracts, and running literal life-or-death systems like flight telemetry or nuclear reactors. The source material actually points out that hardware-level floating-point anomalies have caused catastrophic failures in critical infrastructure before. When human lives and trillions of dollars are on the line, we absolutely cannot let an AI use a hardware gambler to just guess the answers. We need mathematical receipts.
To truly trust artificial intelligence, we have got to fix the hardware flaw sitting right underneath it. We must demand deterministic accountability. It is absolutely crucial that we move our systems away from this foggy, unauditable realm of probability and guessing and step into the clear, verifiable light of absolute determinism.
So I want to leave you with a rather provocative thought to ponder today. If the invisible physical engines powering our entire digital world are secretly liquidating identities and relying on proprietary, hidden approximations, who really owns the truth? I encourage you to always question the math behind the machine. Thank you so much for joining me for this explainer, and as always, keep learning.